So when a business is created when something like Uber happens, that phenomenon creates things happening in the insurance industry. It creates things happening in the advertising industry. It creates things happening in the hotel and restaurant industry. And so we can go look for those things because we have the observation and then we know where to go look. This is our data center in 1964 or so. It was a mailroom and a bunch of cards came in. We mailed stuff out. Are you still there? And they mailed it back. Yes, we are, right? That was a signal. One of the things that we have to think very hard about as purveyors of this ship that's been traveling for 175 years, and you don't get to screw it up, is that the behaviors and the capabilities that have made us successful so far, and this is true for everyone in this room, are just table stakes. There's a whole new set of stuff that we need to get good at if we're going to be relevant in this world I'm talking about. And I'm going to actually give you a list of some of them in a minute. So someone asked me to just talk briefly about how do we collect our data. And I'm not going to, we could spend a lot of time on this, but just at a very high level, there are three basic models for how we collect data. One is a very sophisticated model. This would be like what we do here in the United States. We've got tens of thousands of sources. This number is probably closer to 30,000 now. And we've got a set of rules, and we've got a set of machine algorithms that learn from seeing signals, and they can sort of triangulate on the truth. And we don't necessarily have to even see this happening. We can create millions of businesses hands-off with a set of very highly adjudicated, highly tuned rules, and then we can test that over time and make sure it's true, and we can do all kinds of cool stuff. We still do some degree of manual investigation. We still do some degree of adjudication. It's not all automated, but it's very, very highly automated for the instantiation of the business and for the collection of the data that goes into the scores and things like that, because there's a lot of data that's available in some place like North America. In some place like, I don't know, India, not so much. Right? There's a lot of very small businesses that are very hard to see. There's many different ministries. India is not really, it's a country, but it's really, each state has its own rules around how you register businesses. There's a Ministry of Small and Medium Enterprise. There's micro businesses. What they call a business in India is very different than what we call a business here. Even the word business means something different. So one of the many things that we do in a place like India is something called recursive web discovery. We just got a patent on this a few weeks ago, by the way. It's what you do with your brain. It's not web mining. This is not web mining. It's what you do as a human being. So if I said to you, can you please find out if there's a company called Caution, Content's Hot, right? You would go, how does it know? Anyway, you would go on the internet, right? Like any self-respecting person, and you'd Google the company name, and if you found something that looked like a website, you go, yeah, right? And then, you're smiling because probably you should do something else, right? So if they have a name and an address, you probably want to go and look at the employment listings, or you want to look at LinkedIn and see if people are mentioning that company, or if only there were a product that did something related to this. That was it. If only there were a product. Never mind. We can do something a little bit better than that. But the reality of what recursive web discovery does is it actually finds the places that it can most often go to find more of the story or triangulate on the truth. It keeps track of the legal terms of whether or not that data may be permissibly used or not. It keeps track of where it found wrong information that ultimately turned out to be wrong, because knowing a good source of wrong information is just as good as knowing a good source of right information. And then it basically recursively learning, each step is based on the learning of the previous step, triangulates on the truth. So that's one of the things that we do in a place like that. We also have call centers. We also have data sets that we buy that we know are high quality and are trustable. And then we have, the same investigations and all the other things that we do. And then in other parts of the world where we can't even do that because it's not a digital culture, some countries in the Middle East, I don't want to pick on any place, we might have to just get in the car and drive around and talk to people. And we might have to look at maps, and we might have to look at phone books, and we might have to, so there's still some of that going on. So there's a combination of these three models going on all over the world. As I said before, the data is updated millions of times a day into about 800 different databases from 6 different global data supply chains. So this is a pretty big dynamic environment that you're touching the end of, right? And I won't go into too much detail here, but here's how we look at it internally, right? So we have all these sources, we have all these countries, we know about their laws, we know about the updates, and then we look for new things, signals, observations. How can we create new intelligence out of that? How can we make scores more predictive? How can we answer questions we couldn't answer yesterday? All the stuff I'm talking about right now is in this environment. And then there's also these sort of epistemological challenges, like how do we know when there are new sources? How do we become aware of that in a big data world? What happens when the laws in one country say you have to keep all the data here, and the laws in another country say you have to keep all the data over here? You can't do those both things simultaneously, right? So we have these logical syllogism traps that we have to keep track of all the time. And then, how do we prepare for the unplanned events? What happens when there's an earthquake, a tidal wave, the thing happens, and all of a sudden everybody expects our data to still be correct a minute later? Do you realistically believe that to be true? Of course not. So what are we going to do about that? So I'm going to use the traditional model of science, right? What do we see? Here's a company that really keeps me up at night. Box Park. Anybody know about this? You can buy a company from them. These are shipping containers. And your inventory is in these shipping containers, and they're connected with electrical pigtails and everything. And they basically ship this store to wherever you want it. They'll call it whatever you want. It's not called Box Park. You could have the Hello Kitty Mall and the bathing suit shop and the Christmas tree store in 3 different parts of town at 3 different times, and your inventory is kept in some warehouse, and you swap out these shipping containers, right? So the business is the business, but the name of the business and the location of the business are sort of fungible. Guess what we do to notice a new business? Name and address. Whoops. Ruh-roh, right? I already talked about the fact that more than half of the language that we can observe is not in English or in the Roman alphabet anymore. We are all over this problem. I won't bore you with it right now. Make my day and ask me about it later. Like we just do so much in this area, right? This is meant to inspire you with unstructured data, right? So a bunch of data that we collect that's not neatly organized within ontology and canonical forms and things that we can recognize. So do we have the ability to pick out the data when it's not neatly organized for us? And then there's how we're reacting. So we've got like green stuff, red stuff, and yellow stuff. So the green stuff is the stuff that's probably good for us. Globalization, everything's connected to everything. It's a little easier to see who's doing business with who, right? With whom. We talked about big data, unprecedented business relationships, eBay, power sellers, all these different kinds of things create different data footprints that we can see if we go looking for them. The red stuff, regulatory changes, new types of malfeasance, we talked about that. That's probably headwinds for us. That probably makes it harder. And the yellow stuff, like the prolonged economic uncertainty and disruptive evolution, these are things that if we get on them right, and if we take the right advantage of them, they can actually help us. If they don't, they will swallow us whole. So it's up to us. And so you might ask, well, what kind of new skills do you need to deal with challenges like this? You might ask, what kind of new skills do you need to deal with challenges like this? You might ask. What kind of new skills do you need? Oh, thank you. Things like semantic disambiguation, the ability to take things apart and see what's inside them when they're confusing. Things like linguistic integration, taking things that are written in one language and another language and combining them together. Things like fraud detection, understanding permissible use, data science, right? These are the kinds of new skills that we need to survive in a world like this. So when I look at my team and I challenge myself to whether we're just talking about this or we're doing this, that's something about what the list looks like in the job description to make sure that we're hiring the right kinds of people. Let's take a look at this one for a second. This is a bag from a shopping mall. I was in Japan. Does anybody here speak Japanese?
Very little bit.
Okay, so I was in Akihabara, and I was buying all my goodies. It's like the geek town, right? And you don't need Japanese for this, but I'm just curious whether you knew about Akihabara. So this is the bag. I took home all my electronic, my USB missile launcher and my, hard drive, 17 terabyte hard drive that fits in all that stuff, right? And this was the bag, and I thought it was kind of cool, so I took this picture. And then I realized it's a good metaphor for unstructured data, because the brand, all this stuff is squished together. What do you see?
Some of the names I recognize.
Like what? Mitsubishi. Is that Mitsubishi Bank or Mitsubishi Electronics?
Depends on
I know you don't know, but looking at that, what do you think? Why? Because you're a human being, you have a brain, right? And you can read the context around it, right? So semantic disambiguation, one of the skills is to look at the context and not just the content, right? That's a first order observation. You sort of found all the brands in here. Some of them are in Japanese, in kanji. So we might conclude that those people are only interested in communicating with people who can read Japanese. In some cases, we have different trade styles for the same company. I'm pretty sure Sony and Imation, I think that's the same company. It doesn't matter. Some of these are like the same company with different brands. So the second order observation is that some of them are more interested in dealing with the Western world than others. Let's look at another secondary observation. What else can we conclude by looking at this?
The bigger companies have the larger.
There you go. The ones who bought more real estate paid more. So now, like I could do the megapixel density on the Pope pictures. That's really hard to say. I can do this, right? I could do the size of the brand and build like a histogram of who paid more. What else?
Some people aren't going to be able to read all of it because they're colorblind.
Well, yeah. Color might be used in some way that I don't understand. I'm not a marketing person, but I have one with me. There might be, what else? I mean, really easy stuff. They're all advertising in the same place, so that makes them competitors, right? They all paid the same advertiser. That makes them all customers of that advertiser, right? And on and on and on. Now, you're just looking at a little picture here. Imagine if you had, I don't know, a few billion rows of data. Do you think we could do this at the speed of the internet and do something really super cool if we thought about it a little bit? We do, by the way. So that's kind of cool. This is the same word cloud we had up the front. These are the problems that our customers bring to us. I want to make the right decision at the right time with the right person. We all say these things, right? Total risk, total opportunity. But the reality is that as companies get smaller and smaller, why would you use the same data to make the decision? Why would you look at our data and look at the year started and the number of employees and the with a very small company that started yesterday and has one employee? What other data might you want to look at to make a decision about a smaller company than a larger company like GE or the Bank of China? And do you actually break those down in your decision-making process and consciously stratify the data attributes that you're using to make that decision? And when the company gets really small, this is the Fractal Academy of Sciences. It's a math tutoring place near where I live. I am so tempted to open the door to see if there are smaller fractal academies of science inside. But it's a single location. There's probably very little data about them. Maybe we want to look at the person instead of the business. So these are the V's of big data. When you talk about big data, you talk about volume, velocity, veracity, variety, value. Big data becomes big data when these V's, two or more, one or more of them, overwhelms your best attempt to deal with them. So big data is not just I have a lot of data. Big data is I have so much data that there isn't a database big enough to put it in. Or it's changing so fast that I can't get it all in one place fast enough to ask a question because it's changing too fast. Or it's in so many different languages or so many different types of ontology, of structure, that I can't compare this half with that half. That's when it becomes a big data problem. So what I've done here for you is I've thought quite a bit about what new skills do we need to deal with each of those V's. I promise not to go through all of them right now, although I would love to. What are some of the risks of not doing that? What happens if you just ignore me? And what are the inconvenient truths that are brought to the table by that V? So I'll just give you an example. In velocity, there's this myth of real-time data. Everybody thinks they want real-time data. Guess what? Data you collected yesterday is not 1 day old. I'm sorry. Something created it. And there's a whole life of that data element up to, and yet most of our systems keep track of the update date. When did we get it?
Yeah, they do.
Right? Well, you know, if you go on the internet right now and you look at the horrible earthquake that happened, and there's several you could pick from right now, unfortunately, but the one in Ecuador comes to mind, right? You'll find articles that say that, I don't know what we're up to now. Hundreds of people were killed, and then you'll find other articles that say 5 people were killed. Does that mean the ones that say 5 people were killed are wrong? No, it means that at the time of publication, that's all they knew. Right. And so you're looking at a snapshot, right? Census data is like this, right? You got this shutter that opens and closes, maybe every year or maybe when they decide to fund it, right? But something happens in between, and we have to be able to think about when did that happen. I'll just do one more. What we talked about in variety, the data that exists, but it's not available. You need to think about it. You can't just ignore it because you don't have it, right? Okay, so I would encourage you to spend a little time defocusing your eyes and thinking about some of this stuff, because we behave as if it's all under control, and it's horribly not all under control. Truth be told, in any enterprise, we're just barely on the edge of being in control of this type of a problem. We have printouts over here, by the way. Yeah, you're more than welcome. I just want to save you the trouble.
I just need to create more data.
Okay. And then tweet it, right?
There we go.
So, and by the way, anytime I stole somebody else's work, I tried to give you the provenance because I know who I'm talking to here. So. Don't I get credit for doing that? Okay.
Have a date?
Yes, last updated.
Don't! So this is just a graph showing social media, right? When we say social media, what do we mean? And everybody thinks they know, but they all mean different things, right? So we don't have a lot of time, I'm not going to get into it, but you know, YouTube is social media, so is Twitter, so is LinkedIn. Those are very different types of content, right? So what we've done is we've said, all right, we're going to just sort of do a little progressive decomposition here. We're not going to try and look at everything because we're just going to get an inch deep and a mile wide and nothing's going to happen. So we decided primarily to focus on the printed word. Now, it doesn't mean we're ignoring geospatial inference and all the other stuff, but primarily, most of our data science research right now, most, not all, is on words. And particularly on people sentiment and signals. And I'm going to just take you very quickly through the journey of where we are in that. So when we look at people, there are these three fundamental problems. We have patents in this area. We've really thought this through and worked very hard on this. The three fundamental problems, the John Smith problem is that there's more than one person named John Smith, right? The opposite of that is the Sybil problem, where there's people that go by more than one name. Maybe they go by one name socially and another name professionally. They get married, they change their name. There's patronymics in Russia, blah, 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 right? And then we have the Ann Taylor problem. Ann Taylor is not a real person. There's no real Ann Taylor. Sorry to crush your hopes, but Louis Vuitton is, and so is Edmund Gilda. I cannot say this guy's name, Jenga. I just can't say it. That's my homage to using this slide in other countries. But in any event, the point is that sometimes businesses are named after people. Sometimes there's somebody walking around named Ann Taylor, right? And there's a lot of data about the business Ann Taylor that's not about that person Ann Taylor. And there's probably more than one Ann Taylor. So these problems kind of multiply. And so we have a canonical form for how we curate and disambiguate this data. B1 is the business we're interested in. P1 is any person that works for that business. B2 and P2 are respectively some other business and some other person that works for that business. And then we have these vectors, right? So a business can talk about itself. A business can talk about a person that works for that business. That person can talk about their business, and so on. So as we curate the data, we try to ascribe one of these vectors to it. And this is the semantic disambiguation part. This is what we're really doing behind the scenes. And these are our questions that we're informed by. Who's speaking, about whom, how do they feel, and in what context? Those aren't approximately the questions, those are exactly the questions. And there's not five, there's those four, because they're hard enough. And if you think about it really hard, the truth will emerge about why those are really well thought through. Those are the right questions. And this is very quickly something about what the answer looks like. So normally we collect a whole bunch of different data about a company in order to be able to know that this version of Alpha Plastics and ABC are really the same company. Maybe they have the same address, the same phone number, the same owner, that kind of thing. So there's rules, right? Well, when you start bringing people into it, by the way, these are the patents I keep talking about. So these are just examples. There's many of them, but these are just some examples of them. When you start talking about people, it gets a lot more complicated because people's identity is a lot more fungible. It changes much more quickly. We tend to adjudicate our identity, right? So I might tweet for professional reasons under one Twitter handle and for personal reasons under another, and somebody who's younger than me says, I don't care, and there's all that kind of behavior, right? Basically what we do is we collect a bunch of what we call indicia. These are different types of data elements that appear to be about people in the context of business. And then we do something called dynamic clustering, which is basically, as of this instant with the data I know, do I appear to have enough information to congeal around, we call it a soul. There's no religious context here. It's just we need a word for who the person is. And when we make that, this is called proto-cluster transition, when it moves from a bunch of uncurated data to what appears to be about a person. And then when we get enough of that proto-cluster transition through dynamic clustering, we have a unique persona. And then we can start to attach behaviors to it, looking at fraud rings, things like that. Eventually, we can take a bunch of people, like these might be a bunch of John Smiths that all work for IBM and they're all consultants. So this is a cluster of data, and we call this a flock, because it's like a bunch of birds that all look the same, but they're different. We used to call this cluster flocking, but that was unfortunate, so we call it hyperclusters now. And then we might have a bunch of red data that we say one of these John Smiths went to jail. We don't know which one, and so you go figure it out, right? So there's unclustered. There's data that can be delivered along. This isn't done yet. There's no product that looks like this. This is what's happening in the labs behind the scenes right now. So I'm just giving you a little peek at what we're doing, because I thought you might find it interesting. And then these are some of the aspects of language that make that, confound that, right? So there are confounding characteristics of language, like sarcasm and neologism and grammar. And I know you know all about this, so I won't waste your time. There are methods to deal with things like that, like heuristic evaluation. You get a bunch of similarly instructed, similarly incented people, and you have them answer the question, and then you build models that sort of behave like those people, and you do the minority report thing, and you look at optimism and pessimism, and eventually you do the math, and you get the answer. And it's not right all the time, but it's consistently right or consistently wrong, and that's a good day, because even consistently wrong is a good thing, because you can tune it. All right, finally, we're in the home stretch here. I'm going to talk a little bit about the future. So what I was trying to impress upon you just now in that second section is we are really doing some of these things. I'm not just talking about it. Do you believe me? Can I get a hallelujah? Yeah. Okay. All right. Thank you. So now the mindset, finding the truth, right? So this is grow gills or drown, right? We just have to adapt here. The only solution to living in this world is to do a lot more of what I just showed you than what I've showed you. So when I think about innovation, we tend to use the word innovation a lot. And truth be told, I don't think we all mean the same thing when we say it. Most people, when they say innovation, they mean new products, new services, right? What about creating simpler unsolved problems? Isn't that innovation? Haven't we innovated in cancer research?
Yes.
Right? What about new ways of cheating? Sorry, but that's innovation too, right? What about new ways of doing old things? You know, Henry Ford said, if I gave them what they wanted at the time, I would have given them faster horses, right? The car, the automobile, right? Those are new ways of doing old things. What about ways of doing new things, right? So, you know, it used to not be possible to observe the signals that come from a bunch of people traveling to figure out when a city is becoming more important. Now that's easy. Charlotte is the outcome of something like that, right? So, you know, we talk about epistemologies, new ways of knowing. Are we actually thinking through these methods? Are we thinking through how we know what we think we know? And of course, new ways of cheating, cyber terrorism, cyber security. So this was an attempt to do the good, the bad, and the ugly, right? So here's some of the things we have to believe we're going to be able to solve things like this. Famous imposter charged with being an imposter, right? Your brain can fix that. You kind of know what the story is about. The guy got caught again, right? You know, this one I love. I can't see it from over here. FBI hunting San Francisco man with explosives. Who's got the explosives? Every time I walk my dog past my grandfather, he pees on a telephone pole. You know, we sort of know what that means because our brain fixes it, but it's a dangling modifier. It's wrong, right? There was a blind bishop that was appointed to the Holy See. He became a cardinal. Blind bishop appointed to see. You have to know some context here, that it's called the Holy See to understand that. This one's in French. It's funny, but only if you speak French. Here's 112 different ways to spell Muammar Gaddafi's name because it's not written in the Roman alphabet in the English language. And by the way, 15 pit bulls were rescued and 2 were arrested. So, you know, this is from a session that I did with my group around innovation and some questions that you should ask. If you really think you're innovating, maybe you should ask yourself some questions about how you know you're innovating. And I would submit to you humbly that you could change the nouns here a little bit and say, if you think you're doing research, how do you know you're doing research? So this is my word cloud. I made this one. There's no attribution because it's from me. And this is sort of when I think about data and what's happening to data today, that's what I think it looks like. So the bigger words are the things I worry about more, and the smaller words are things I still worry about, but not as much. And ironically, I worry much more about unstructured aspects of data than I do about business practice, because I think we understand business practice pretty well. We've been doing it since the 1400s or whatever, right? All right, home stretch. I'm going to give you an example of kind of bringing this all together. This is connected space. Do we have math people in the room? I need somebody to keep me honest. Come on, somebody has to be a math person. Put your hand up. Okay, thank you. Thank you. I'll be kind, okay. What you're looking at here is, remember we did the thing with the penny and the pennies and the pennies? This is the full-on nightmare version of that. We took all 250 million entities that we have and all 4,000 or 5,000 attributes that are discoverable about those entities, and we connected everything to everything in every way that everything connects to anything. Okay?
Okay.
So we have 2 to the 8th Duns numbers, 250 million, 2 times 10 to the 8th, 2 to the 8th, 2 times 10 to the 8th, right? So 10 to the 8th Duns numbers, and we have 10 to the 3rd attributes. So we get a connected graph with 10 to the 8 times 3 or 10 to the 24th edges, right?
Exactly.
Did I do the math right?
Precisely.
So we have a quintillohedron here, right? This is a ridiculously huge, that's it, that's all the math. We have a ridiculously huge connected space. This is just a little picture of a little tiny piece of it. These are 2 oil companies and all their customers and all their customers' customers and all their vendors' customers' vendors, all the way out to the 6 degrees of Kevin Bacon, right? And basically, they can't see these companies, and if either one of these companies gets the flu, both of them are in trouble, and whoever figures it out first wins. That's essentially the moral of that story. But how do you solve a problem like that? How do you look at something that big? Even as fast as computers are today, and even as amazing as our investigative methods are, there's no way that we can deal with something that big. So how do you go to Disney World and decide what Disney World is like? Right? A bunch of people go, and they all have a different experience, and then they come back and they kind of talk to each other, and then they go again and they compare the first experience. Well, that's what we do algorithmically. So we build a bunch of algorithms. They're called forest fires and snowballs. There's quantum algorithms. There's all these different types of algorithms, and they all do different things. And we launch them into the multihedron at different places. Some of them never come back. The ones that do, we kind of talk to them. We have certain measures that we look at. Anybody here a biology person? We borrow a lot of the terms from biology, like anisotropism, the lumpy parts. We looked at connected places. We look at how many hops it took you to get there. We look at all these different things. And then we dump a bunch of new data into the multihedron, and we connect it to the pre-existing dyadic relationships, and we do that again. And we look at how things changed. And by looking at how things change, and now I can't draw it anymore because it's just too complicated, but you basically have a multihedron of multihedra. And you can start to look at that over time, and you can start to do that with customers' data. And we're only beginning to do this. Don't believe I'm doing all of this already. This is way beyond computer science right now. This we're doing. This we're starting to do, right? And you can start to play what if. What if there's an earthquake? What if there's a tidal wave? What happens to, and hopefully we'll solve something more important than Pop-Tarts, right? And I'm going to show you an example of that. So ultimately what we're looking for is these points of inflection where companies become malfeasant, or where they start to grow, or where they start to die, or where they come to life, or where they, sorry?
No, I just like that.
Oh, thank you. So it's basically, we're looking at that times 250 million, all happening simultaneously and interacting with each other. And so now, much more, our data is not just about the entity, it's about the relationship among the entities. So when you look at our data, you should also think about all the different ways that we can see it connecting to itself, or not. Oh, what just happened? Sorry. I said or not, and I look back and there's nothing on the slide. So, what about intellectual property? What about competitive claims? What about alliances? These are all things that we're starting to look at. It's much more difficult than you might think, at least more difficult than I thought. So we used to worry about this guy. Now we got to worry about this guy, right? We talked about Barbie. We all know not to talk in front of the television because it's listening, right? So there's a dark side of innovation as well, and we got to be thinking about that. And finally, and I promise, I keep saying finally, but I promise, this is the last example I have. I want to tell you a story, and I'm going to apologize in advance. I get emotional when I tell this story. But I wanted to share this with you because it's a good example of the full-on use of data for something more than making another dollar. So when the events happened in Japan, so there was an earthquake, there was a tsunami. The tsunami hit the coast of Sendai. 20,000 people were washed out to sea. And then the bad things started to happen. So the reactors, the Daiichi nuclear power plant, there was radiation clouds, there was all of these horrible, like what else is going to happen? And a bunch of us, I was there till 3 days before this happened. Some of my colleagues that were at the same meeting were there when it happened. We got on the phone right after this happened. And, the usual conversation, is everybody okay? Do we know anybody that was involved? Can we reach out? Of course, as an individual, you think about, can you write a check? Can you help? What can you do as a human being? And then eventually, the conversation gets to the business, which is also important, right? And in Japan, just like anywhere else in the world, most businesses are small businesses. And most businesses are kind of hand to mouth, right? So if they don't get any money for a week, somebody's going to starve. So now we're going to add starvation to radiation and tidal waves and all this other stuff. So not on my watch. So we had a project that was looking at this connected space. It was the project I just showed you, and we stopped it. We took all the people, and we said, you're working on this now. We got to figure out what can we do, because right now we have a database that says all the businesses in Japan are doing just fine, and they're all there, and everybody in the world is thinking they're not there, and they have stopped doing business with them. We've got to be able to credibly say who's in business and who's not, and help the people who are. Because that's something we can do that might matter. So we started to look at how long it would take to use, remember those 3 towers of ways we collect data? How long is it going to take to use the tower that we have in Japan according to the business practice that's in Japan, given the fact that the phones aren't working and the roads aren't accessible and all this stuff? It was going to take between 2 and 3 years to fix the data. We don't have 2 and 3 years. We don't have 2 and 3 years. So we started to look at the data we had, and we figured out that we could go and get a bunch of data. So you're looking here at pictures of the skyline before and after. This is the Ishinomaki fish market. It's not there anymore. This is how your shoes feel, right? How do we teach a computer algorithm to look at a picture like that? Because we don't want to look at one. We want to look at hundreds of thousands of pictures like this. And it turns out that you can write an algorithm, because this is just a collection of dots, right? Each of these dots has a hue and a color and a saturation and and you can walk across it and down it, and you can find the point where the luminous intensity shifts by more than a certain amount and correct for things like clouds and power lines and flying birds, and you can find the skyline. And then you can do a regression equation of that skyline and calculate the missing mass under the curve and compare it to the apparent mass of the front face of a building and figure out whether it looks like it's not there or not without looking at the picture. Do you think I can do that 700,000 times consistently? Say yes. This one here, we find the epicenter of the earthquake, and we put all the DUNS numbers on the map. Big cities in Japan don't number buildings in the order you find them on the street. They number them in the order they're built. So you can't just look at the address. You've got to use address disambiguation. It turns out we already had that capability in our identity resolution, so we stole it from ourselves, and we put it in here. And we put every DUNS number on the map, and we also had, from the fine folks in the Geospatial Agency of Japan, it's not called that, they're ironically right across the street from our office, we were able to get a topographical map, very, very detailed digital map, and we knew not only where they were, but how high up they were, so we could compare them to the footprint of the water. We knew how shook up they got. We had tectonic engineers working with us. We had people who understood the propagation of earthquakes. We didn't make this stuff up. We went and got people who knew this stuff. Actually, some of them were on that project, as it turns out, and I don't believe that was an accident. And we were able to look at curved and straight lines that used to be curved and straight that were broken after the event, so we could assess the impact on the infrastructure. We found crowdsourced radiation data, and we had someone who was an expert in the propagation of different types of radiation. So now we knew how irradiated they got, how wet they got, what happened to the skyline, what happened to the infrastructure, how shook up they got. We actually built 19 different car detector algorithms. This one looks at the shape of 3 squares, and it looks for, I don't know if I have it or not. No, I don't. It looks for 3 squares, and 2 of them reflect light the same way, and 1 of them reflects light the other way. It finds the windshield. We can count the cars. Now, no one of these methods in and of itself is going to tell you whether or not they're in business. But when you start compounding the effect of all of these, and the fact that they're not using the same data to reach the same conclusion, it starts to cross that dispositive threshold and reach the point where it's a useful decision. From start to finish, we fixed all the data in 3 months. And then we had the most valuable data set in the world for Japan. And guess what we did with it? We put it on the internet and gave it away for free. And that's the only thing you can do with a data set like that. So we talk about being inherently generous. We talk about something being bigger than just the data, being bigger than just the research, being bigger than just the question. Even though this is a few years ago now, I can't come up with a better example, and I hope I never do. I'm not going to go through these, but it's very hard to go on the internet, just like how high is the sky, and Google non-regressive methods. It just doesn't work. It's too ambiguous a term. But I'm talking a lot about using different methods of inquiry against big data. And so the data scientists on my team and I have put this list together, and this is what we use internally to challenge ourselves to make sure we're using the right methods. And so what I'm going to do now is give it to you. And you can go and chase down any one of these methods you want and see if it's relevant as a source of inquiry for a particular type of problem. So these are evaluation epistemologies. I've mentioned heuristic evaluation and progressive decomposition several times in this presentation. These are some examples of how to deal with unstructured data like graph mining and thematic coding, which I'm sure you're familiar with, and entity extraction and ortholinguistic disambiguation. Have a fun day. This is all cool stuff. And if you want to talk about any of this, I'm going to give you my phone number at the end, right? Because I'm a dork, right? Data science methods, neural networks, machine learning. We've talked about almost all of this in this presentation. The trick is to go do something with it. This is sort of a rough summary of what I've said about how we have to behave and what we need to believe, and sort of me kind of crystallizing what I think the advice is that I've given here, so that hopefully some of this sticks. And I'm going to leave you with two quotes. These are not random quotes I got off the internet. They're at my desk. I think about them all the time. Albert Einstein said that we can't solve a problem with the same mind that we used to create it. And he also said that everything should be made as simple as possible, but no simpler. So that's my inspiration every day, and I hope it's mildly inspirational to you. And that's all I have. Thank you. If there's any, like, one or two questions, or I don't know, we're kind of right at the end of when you asked me to stop, so it's up to you. I have to thank you, because I kept going because I was getting a lot of energy. You're all in the moment with me, and I really appreciate that. This is really, what a great time to be doing what you're doing. What a great time to be in the age of making sense out of this stuff, right? We get to not screw it up. Yes, ma'am.
So, I can't give this presentation to the person who asked me how recent is this data.
Uh-huh.
So what would you say? Because we all get that question. It's
Yeah.
like, how recent is this? So what would be the simplest two-word answer to that question?
Consistently recent would be if you made me give you two words and only 2 words, but you said 2, right? If I only had 2 words, that was pretty good. Consistently recent, right? So one of the things that we look at, and let me just confine my comments to answer your question to North America for a second, because I just know the numbers off the top of my head. I don't know the numbers for the whole earth, right? There's about roughly 18,000 public companies in the United States. So they update their data with a 10Q and a 10K, and we kind of know there's this mensural process. We know when the next one's coming. We know when to go look for it, and we look for it just after it's there, and we go and we get it, and big deal, right? There's also 27 million companies that are not public. And so for the ones that are not public, we have a process that tries to make sure that we touch them all with enough recency that if we went any faster, we wouldn't pick up much change, and if we went any slower, we would miss important things. And so that process, that intelligence engine that I talked to you about, is tuned to do that at about the right pace to capture the vast majority of change. Now, while I'm saying that, the person who's asking you how recent is this is holding some flaming example of something that's wrong, right? And, you're never going to stop the Aunt Mabel, like, this drug is great. Yeah, but my Aunt Mabel, she took it. And there's always going to be that one, and I'm not trying to be unsympathetic to that person who, right?
Honestly, your answer is a lot better than any answer I
Okay. It's the best one I have, right? There's a lot, what is that? Oh. There's a lot of work that gets done to look at tuning the recency of updates so that we're not wasting money going, how do you feel? Fine. How do you feel? Fine. How do you feel? Fine, right? But that we capture, is this still your phone number? Yep. Is this still your phone number? Yep. When I first started working at D&B, there were these tapes. I don't think we have them anymore. I wish we did. of like really funny things. We used to make like, I don't know, 50 million phone calls a year. We do this all much more automated now. Pay no attention to that screen going up and down. And it was one of the call center people calling, and they read a script, right? Hello, the person goes, hello, Shady Rest. And they go, is this the Shady Rest Funeral Repose Home? It's a graveyard, right? Yeah. Are you still at, 409 Market Street? It's a graveyard. And the guy hangs up, right? You probably don't have to call them and ask them if they're still there, right? So we built algorithms that are a little smarter than that, and they know when to look for, the smaller, more dynamic businesses. We have sources that are more sensitive for picking up change. I don't want to start quoting numbers and then be wrong, but the very small, very new business obviously changes much more quickly. About 50% of that identity changes in a year. Mm-hmm. So it's a really scary rate of change. So when I talk about those millions of updates a day, it's partially because of that. It's a Red Queen problem, right? If we turned the crank harder, we would spend a lot more money and only get a very little bit more change. So we have to get that right because we also don't want to throw money out the window. That's the best answer I can give you.
No, that's yes. Thank you very much.
Okay.
What other common questions do you get, since we have Anthony, who's the expert? You did a wonderful job, thank you.
Thank you.
What other common questions do you get about data? I know that's certainly one of them. We've heard that a million times. Is there other common questions?
Well, maybe about more like emerging industries rather than, traditionally defined by the NAICS codes or the SIC codes. Yeah.
Sorry.
But I mean, how would you go into a data set that you're talking about? You have like these millions of records to try to track what may be considered a new industry that's emerging into disruptive
Yeah,
technologies.
awesome question. So how do I know when a company called ABC Enterprises is doing something new? Box Park, right? How do I find the box park? And part of the answer is in signal analysis. So we look at the data footprint of, so suppose that there's a business. Let me give you an example. Let's play a little game, all right? I want you to just go like this. This is going to be a score for how viable you think the business is. I'm going to give you some data about a business. And I want, let's just, everybody do this, but don't look at each other, right? Okay. We have a business that's been in business for 25 years. They pay their bills on average within 30 days. The number of employees this year is more than the number of employees last year. There are no suits, liens, or judgments against this business. How do you feel about the business? Okay. Wait, keep your score up, right? This is when somebody walks by and they see everybody going. Now, that same business, we've noticed that they actually have started to pay their bills just slightly slower. Instead of on 30 days on average, it's more like 60 days on average. Right? And now it's actually 75 days on average. But now I went and looked at other information and I find out that the job listings for this company are up 40% and they're hiring. I don't know what to do anymore, right? It's a non-traditional, you can put your scores down, right? I don't know what to do anymore, right? Because I don't know what to do with that. And the scenario I had in mind was they're hoarding cash because they're about to come out with some great new product. They're hiring people to hit this thing head on when it hits the market. And it's probably the best thing in the world you could invest in. And they're just not paying their vendors as quickly because they need the money to support the launch of the great new thing, right? Another perfectly logical explanation would be that they're hiring people in desperation to try and sell the same old crap that they've been selling all along, and they're throwing good money after bad, and they're going to die. And now I have to ask myself the question, what additional data do I need to go collect to support or refute one of those two hypotheses? This is the use this data to prove blah question. No. Let's establish what we learned in school, a hypothesis and a null hypothesis, and let's go figure out a method as a scientist to go answer that question. Can we do that as librarians? I think so, right? You all have the skills to do that. And I think that, without sounding like I'm preaching, because I'm so inspired by how hard it would be to do what you do in a world that's changing like this is the time to be the shaman. This is the time to say, there's another data set that you can look at. There's another way of looking at this data. Let's talk about the data you can't see and how what we know about it, even though we can't see it, that speaks to the character and quality of that. Does that make sense? Mm-hmm. It's really cool. You know, if I said somebody just walked by and none of you saw them, and it's a really famous person, it's not true, but imagine that somebody really, you're all thinking, who was it? Who did I mean? Right? A really famous person walked by, right? All you know is that a really famous person walked by. But immediately you would say, well, who was it? And I would say, I can't think of his name. I just gave you a clue. I told you it was male, right? His name, right? Was he old or young? I don't know. Now you're gonna. What do I consider old and what do I consider young? You got to look at me, right? He was 49. He was young, right? So you know, we're doing this all the time with this amazing neural network that we have. We just have to pay attention to it. I'm just trying to inspire. I know I'm not really giving you an answer. But.
Well, Walmart comes to mind when you say that because it changed drastically.
Yeah. And you know about the whole, healthcare vitamins thing.
Mm-hmm.
You must be pregnant. I don't think that was Walmart, by the way.
No.
Target. You know about the Skin So Soft? That's a great one. The whole demand signal thing with Skin So Soft. They came out with Skin So Soft and hand lotion. Sorry. P&G. Okay. When they first came out with it, it was one among many things that do the same thing, and it kind of, I don't know, they advertised it and it was lukewarm, and then they were about to kill it as a product, and all of a sudden demand went off the well, yeah, they didn't know that at first, right? So they make more trees, I'll get you more trees. They start making it as fast as they can, and by the time they get it on the shelves, nobody's buying it again. And then they're about to kill it, and then all of a sudden everybody starts buying it again. And then some genius figured out they're buying it in the warm weather, and it was a good mosquito repellent, right? So, let's make some new mistakes. But, if you think about where you sit, right, as the gatekeepers of the curated information that we understand, you also sit at as the gatekeepers of the uncurated information that we don't understand. And that's a pretty ominous place to be sitting. What a cool thing. Yes?
So, the people, I'm going to just speak for myself maybe for a minute. The people I help to start a small business are very unsophisticated.
Yeah, and they don't care about any of this.
Well, they do because they care about the things they don't understand a lot more than the things that they do, obviously. And so one of the things they don't really understand is now that all these businesses are living not in a, they only understand how to look things up in a phone book maybe, or maybe how to Google. So one of the things they don't understand is how you're capturing businesses, or what your plan is to capture businesses that don't live in any kind of phone book anymore.
Yep.
It's not. So what would be a way to talk to them about that?
Okay, I'll tell you how I really do talk about it, because it's a good analogy. So the setup is, I'm having a conversation with somebody who doesn't know what they don't know, right? And I'm probably not going to be able to talk to them about all this thousands of sources and curation and discovery and accuracy. They're going to hear blah, 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 but it's Charlie Brown. Wah, 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 wah. They're not going to hear that, right? The analogy that I find works really well, because we can imagine it, is if you're camping and somebody wakes up in the morning and they say, I heard an animal walk through the campsite last night. And imagine you go out and you look, and the animal was an elephant, right? The elephant makes big footprints, it breaks things, it poops. It's pretty obvious when an elephant has been there. But if it was a mouse, the trail that it leaves is really, really small, and you may never find it. So our job is to find those mice. More businesses look like the mouse than the elephant. And so what we have to do is we have to constantly be vetting new ways of looking at the sources we already have. Like, as an example, one of the pieces of data that we get is trade data, accounts receivable data. Right, so trade providers provide to us in bulk, here are our customers and how they pay their bills. And we promise to keep the identity of those entities secret. There's nothing you can say to me that will let me tell you who those trade providers are or who their customers are. I'm not doing it. You have to fire me first. But what does it mean if I get a piece of trade and I can't match it to our database? What it used to mean was what we called an unmatched piece of trade, and they would throw it on the floor. Now it becomes a signal. It's called a single source record. Somebody thinks that this is a business. In fact, so much so that they extended terms to them, and we don't have them in our database. And so the known unknown becomes the first clue that a mouse walked through the campsite. It's not in the phone book. In that case, it's in a piece of trade. It might be in a UCC filing. They leased a copier. It might be in a lawsuit. Very often, businesses get sued by the wrong name, right? You want to sue somebody and you don't know exactly the name, so you get it kind of wrong. And, I'm trying to write my name, right? It took me till 3rd grade to learn how to spell it. So, they go to sue the company and they get the name spelled wrong. Misspellings, sometimes when the variation is bad enough, become unmatched, right? Well, is that unmatched because there's actually a company out there with that horribly mangled name, or is it because we don't do a good enough job of doing, linguistic variation and all that stuff, right? So, sometimes we use this as clues to tune what we do, to make it better. Sometimes we use it as cues to say something's there that we don't know, the known unknown. And sometimes we use it to corroborate things that we suspect might be true, that we just needed one more piece of information that's uninformed by those others to make it cross that dispositive threshold. But the mouse and the elephant work. And if you say poop, people laugh and they remember it.
So one of the trends right now in business is the gig economy.
Yep.
So very, very small contracts. Is Dun & Bradstreet doing anything to respond or provide any information about
I'm
that?
sorry, I couldn't hear the
There's no-
question.
right,
I can't hear.
One of the trends in business right now is the gig economy. And so I'm wondering, is there anything going on right now that would be responsive to that, or is that just a?
Of course, it's something we care about. So let me rephrase your question to a more answerable question. Transactions among business entities are becoming more voluminous and smaller. And it's harder and harder to see very small, very frequently occurring things. Is that fair? Okay. So the big data problems there are velocity and variety. And they do overwhelm the system because we're looking at things like, credit terms and, lawsuits, and you're not going to see any of that microfinancing. It's not going to show up, right? So without getting into intellectual property, there are many things that we do to try to capture that. A small business will often use pieces of accounting software. They will often inquire upon other small businesses. They will often seek credit from a bank, like they'll seek a line of credit. They will often do things like look for a small business loan, which is, I guess, a lot of credit, but a different, not like operating credit, but like I want to grow my business, right? So what we do is we look at a lot of those endpoints so that when a small company interacts with a big company, we may not be able to see the small company, but we can see the big company interacting with something we can't see. And that becomes a signal that helps us go look for that. That's the best way I can describe it. I can tell you more, but not on tape in front of 50 people, Okay. And I know it's not tape. Okay. One more Mercy question, or are we good?
No, actually, we really appreciate your time.
Not at all. I take the signal of I'm watching the faces, right? I'm smiling with you. I really thank you for being such a great group to talk to. I really appreciate it.